Okay, our next speaker is Greg Clark, Defense and Aerospace Markets Senior Manager at Qorvo, addressing RF front-end challenges for next-generation space applications.
Thanks, Pat. Hi, everybody. Thanks for letting me speak. Thanks to Fabian for the quantum radar information, Brad and Mike. We're going to see some common themes, I think, from my presentation, but I'll focus more on the RF side of things. So my agenda, I do have the abstract in here. I won't read it. I'll save you that. I broke it up into two groups. One is the challenges of the RF front end. This is not just the technical side, but also the programmatic. How do you get it into space? What's required? And then I'm going to circle back to similar slides and talk about how we're addressing those challenges or how we think they should be addressed. And then I'll give a brief summary. So rather than reading the abstract, when I was asked to give this presentation, I asked my team, what should we talk about? And that was, so I asked a combination of engineers, a combination of program managers, and we came up with a series of what's hard, what's difficult in what we're trying to do. So from RF front-end challenge, why is it difficult? It starts with the L through Q band coverage that we're trying to achieve with ever-increasing operational bandwidth needs, always the ask for better power outage efficiency, higher power, lower noise figure, multi-mode operations. And then also now the push towards E and V band. Carry that forward, broke it into transmit and receive. As I said earlier, it's a large range of power levels. At L band, it's different than what's power level at Q band. The wider bandwidths. In the past, I remember, I want 250 megahertz bandwidth in this frequency band, instantaneous bandwidth. Now I'm getting asked, I want 750 megahertz instantaneous bandwidth in this frequency band of operation. Peak power, PAE, linearity requirements, those three don't always mix. If you look on the Smith chart and do a load pull analysis, power and PAE aren't overlapping very well in lots of cases. And then linearity is a different animal in its own. Low dissipated power, so everybody wants all this power on the transmit side, but they don't want to have the expense of the DC. Where there's some limited bias adjustment, and then the ever request for, I want it as small as I can get it. Kind of on the receive side, very similar. I want the lowest possible noise figure. I want the lowest loss circuits before I get to my LNA. How do I get that? Is that a package device? Is that a bare die device? Again, low dissipated power. I worked on systems years ago as an engineer, and the receive side dissipated power was actually worse at the system level than the transmit side, because the transmit side was only on for milliseconds, whereas the receive power was on for seconds. Single bias operation. This helps with the board routing of the boards and getting everything into the small size. High IP3. We talk about the swap C. Mike and Brad, you did a great job talking about this as well already. So size and weight, from the Qorvo perspective and from my team, this is the packaging and the implementation. What form factor are we going to put the PA, the receiver, all the circuitry into? Is it going to be in a plastic overmold package? Is it going to be in a ceramic package? Does it have to be hermetic? And then the implementation of that. From a power standpoint, it's the dissipation. How are we going to get that heat pulled out of this system? And then the efficiency of the PAs. And then finally, cost. One of the things I want to touch on here, because it came up talking to my team, is screening and reliability, and then also the component count. Why that's important is now in these LEO in this LEO market, where we're starting to see thousands of satellites being proposed to go up into space, is how do you space qualify everything and still keep it reasonably priced? So, and that's what this slide kind of talks about. We're being asked to provide fully screened space products, but at a cost price. They want some commercial off the shelf, but they want it to be fully screened and ready to go into space. So we got to find that happy medium. We need to balance the mission life against what the required screening level is. So the mission life is 3 years. Let's not plan on 20, because it won't be there. We need to navigate the program goals against the reliability requirements. And then we also have to look at, again, as I mentioned earlier, large volume deliveries of product, front-end modules, the DSPs, anything that goes into the system versus the device screening. Is every single device going to need to be screened? And now I'm going to go back through those similar slides, but I'm going to propose the solutions. So the frequency bands, Qorvo, ADI, others, they have it well covered as far as L-band through Q-band. Q-band is kind of an emerging area today. E and V band will probably be the next generation of processes. And you can see here various, some of it's plastic overmold, some of it's a ceramic or a copper-based package, flange package. And then as you get to higher and higher frequencies, you're going to push into pretty much a bare die solution until we get better packaging. So talking a little bit how to address some of these Satcom needs as it relates to heterogeneous integration. So the Satcom needs, they're on the, I guess, the left side: system specifications, architecture, packaging, heat management. From the heterogeneous packaging standpoint, well, the system specifications, that's your TX power, your RX noise. That's integrating the right chips into the right process or into the right package solution. Architecture, now we talk about, is it a planar array? Is it a slat array? Is it a SSPA going onto a different type of antenna? Where can we simplify the power management? That's PM up there, as well as simplify the interface. Packaging, now we have to, how do we use the right capabilities at the device level to get the best possible solution for the package? So we're looking at flip chip technology, low-cost substrates, moving away from the ceramics, more to the organics, and then also assembly with this heterogeneous integration. And I have a slide coming up that shows a cartoon of that. Heat management, again, going back to some of the packaging. What's the best way to get the heat out of this in the smallest possible package? And how do we simplify the cooling inside the system? Swap C, again, it's all kind of interrelate, but it's how do you integrate all this together in order to get to the best solution? And then time to market, this goes back to, we have to have the right design, has to be manufacturable, needs to be assembled, it has to be tested to the schedule of the satellite launch. So this is the example of one of the value solutions. There in the corner, you see a package, a heterogeneous package cartoon. This has the, if you can read it, the antenna board. It has a laminate interposer, and then you have the beamformer chipset, the power amplifiers, the LNAs, all integrated together. You have your heat sink on the top side of the package versus on the RF signal, DC signal side of the package. To me, this is, it's not the only future, but this is part of the future of packaging for not only Satcom solutions, but other phased array solutions. There in the middle, you see an example of a board that we built. It's actually not, it wasn't specifically for Satcom, this was for a 5G application, but the same technology, the same principles apply, of a multi-chip module with a beamformer and 8 channels of transmit receive. integrated together in a single package. The major difference with this package versus what's shown in the cartoon on the bottom is it's all heat side down with the RF signal, so it's more traditional packaging. It's not full 3D. And if you remember, we talked a little bit about the programmatics, the quality and reliability. It starts with communication or collaboration with our customer, making sure that we're on the same page with our customer base, the system engineers, on what they need from a qualification for their mission. We want to select the best-in-class products. We want to use the products that have space heritage as preferred, processes that are space qualified or have heritage, as well as packages and capabilities that are known to have flown in space. We want to be able to reduce the component count through reuse. Where we don't have that, then we have to start looking at, well, what do we need from a qualification standpoint in order to get that process qualified or the product qualified. With our customers, we start with the foundation of the standards, JDEC, MIL, NASA, ESA, in the case of the European agencies. We want to work with the customer to define that screening approach. Let's only test the value-added tests. What's important versus testing everything and checking the box. And then we want to optimize that test plan for the mission. Is that sample testing? Is it 100% testing? What is that definition? And again, it's not us as a component supplier telling you, it's collaborating with you to find out what the best solution is. And then that's the streamline of the qualification. And that last bullet, probably the most important, have that open dialogue. It's a two-way communication. It's not one way. Customers shouldn't be saying this is what we must have. It needs to be a conversation versus a mandate. Something else that I find to be important is end-to-end expertise. At Qorvo, we tend to be known as the component supplier. There are system engineers, so it's with comprehensive knowledge of Satcom systems. That way we can collaborate with the customers versus dictating and then we want to leverage our design and capabilities. If we don't have it, then we want to look outside and go to the people that have it. And then again, work with our system architects and our design engineers, our apps engineers, our project managers, so that it's a solution for the problem at the system level. And then finally, this is the team I asked. If you had a chance to talk about something, what would you want to bring up? So Ed Peak is our product line manager for Space Solutions. The three in the middle, Lisa, Mike, and Chris, they are Defense and Aerospace account managers. And then Salvo, I won't even try to pronounce his last name. He is one of our principal system engineers that I spoke about just a moment ago. Thanks.
Any questions?
So Greg, as you look at the evolution, you talked about heterogeneous integration, and of course you've got sort of two dimensions, the geo satellites and the LEOs now. Is there a common thinking today about hermeticity or not hermeticity from a reliability standpoint?
I don't think there's a common theme yet. I think it depends on who you talk to. From my customer base, I hear a lot of, it has to be hermetic. I will tell you right now, Qorvo doesn't do hermetic packaging. We do have HAST compliant capabilities. I personally think the tide is shifting away from a hermetic solution, more traditional space, to a just good enough, which would be HAST compliant, or even almost a commercial off-the-shelf compliance to the space solution, especially in the LEO market, where you have a 1 year, 2 year, maybe a 5 year life. You just don't need that level of space qualification. But that's been a challenge, working with what I call the traditional space reliability engineers. It's been hard to have those conversations and have them check off the box that I'm willing to sign my name to this, even though you didn't do all the testing. So.
Anyone else? Okay, great.
Thanks, everybody.